or solve problems. First starts with a roller coaster moves 85 meters horizontally, then travels 45 meters at an angle of 30 degrees. So above the horizontal. What is the displacement from the starting point? So you just use graphical technique. Let's see graphical technique. So graphs are very important, by the way. Whenever you are trying to solve this kind of vector problems, what you have to do is it's better to use a graphical method. See, sorry, this coaster is traveling is just moving at a velocity of travels a distance of 85 meters. It's traveling a distance of this. Let's say this is 85 meters. This is 85 meters horizontally. Then, when it travels 85 meters, it changes direction. It travels 45 meters at an angle of 30 degrees above the horizontal. It starts to travel at an angle of this one. That's what. So this is, it starts to travel at an angle of 45 degrees above the horizontal. So we want to find the displacement of this object graphically. What is a displacement? A displacement is a point drawn from the starting point to the ending point. This is the value of displacement. This is the displacement. This is what? This is the displacement of the object. So how do you find this displacement? Now let's find the displacement of this coaster. So what you have to do is we have to resolve this quantity into its horizontal and vertical components. Let's see. What you have to do is you just resolve this into its corresponding components. See? So this is, let's say this is D1, displacement 1. Let's call this is displacement 1. And call this is displacement 2. And this is dr, the resultant displacement. Let's agree that this is dr. So in this case, the second displacement has two components. It has a horizontal component and a vertical component. We can just divide them into two: a horizontal component, a vertical component. Or, if you like, you students, you can prepare a table, like a row or a column consisting of. You can just prepare a table if you like. You can prepare a table that is, this is the vertical component, and here you can put all the components which are acting horizontally. Then you can compare. Now for me it is better, let's find d to x and d to y. So to find the horizontal component of the second displacement, I can use cos. Here I know cos, but we know that d1 is, don't forget that, bear in mind that d1 is the first displacement is 85 meters, and the second displacement is, that's 45 meters. We know that, these are the given. And the angle that the second displacement makes with the horizontal is 45 degrees. We should know this. Oh, sorry, I'm sorry. The angle is 30 degrees. Really sorry. The angle is 30 degrees. This angle is, it's not 45 degrees. It is 30 degrees. I'm sorry. It's a 30 degree angle. So the angle that the second displacement makes with the horizontal is 30 degrees. This is 30 degrees. So let's find the horizontal component and the vertical component of the second velocity. That's d2. So I know that cos 30 degree is defined as its adjacent side. This is the adjacent side divided by the hypotenuse. This is d2x. We know that this is given by, this is the horizontal component of d2x, and this is d2y. So the cosine of 30 degrees is adjacent side divided by the hypotenuse. That is d2x divided by d2. So cross multiplying and making the subject of d2x the subject, this is given by d2 multiplied by cos 30 degrees. And this is the same as, and d2 is given by, d2 is here, is 45 meters. 45 meter multiplied by cosine of 30 degree. You can use calculator. Cos 30 is, you can use calculator straightforward. Take out your calculator and just try to find cos 30 degree. Cos of 30 degree is root 3 over 2. It's 0.8666. This is 0.866. Just multiplying this, you will get, multiply this by 45 and you'll get 38 point, almost this is 38.98. This is almost, I can say this is almost 39. This is the nearest whole number. This is 39 meter. This is the horizontal component of the second velocity. Same way, let's find the vertical component of the velocity. What does the vertical component looks like? So I can use sine. A sine of 30 degree is equal to the ratio of opposite side, that's d2y divided by d2. So making d2 the subject of d2y, the subject of the formula, d2y will be d2 multiplied by sine 30, which is d2 is given by 45 meter multiplied by sine 30 is half. You can use 1 over 2. So you will get, this will give us 45 divided by 2 is 22.5. If you like, by the way, if you want to check this, take the square of 45 square. By the way, we know that d2 square is equal to d2x square plus d2y square. This is from our Pythagoras theorem. So d2 square is 45 square is equal to d2x is 39 square plus d2y is 22.5 square. So when you just calculate 39 square and add, you'll get the same answer. I'm sure. Check. This is check yourself by yourself. Check by yourself. Now we know d2x, we know d2y. So what you have to do is, what are the resultant velocities? What are the total displacement along x? What is the total displacement along x? So this is given by d1x plus d2x. We have only the first displacement is only along the horizontal axis. That's 85 meter. This is 85 meter plus d2x is 39 meter. So all together we will have, this is the same as 85 plus 39 will be 124. You can use calculator, you will get 124 meter. And the total resultant force along y-axis, I mean the total displacement along y-axis is, we have only one displacement, that's d2y. That's d2y, which is 22.5 meter. Our problem is not yet solved, by the way. These are the total displacements along y and along the x-axis. We want to find dr, the total displacement along. Now I can redraw this as, I can redraw this as here I have d2x is, here I have d2x, this is d2x, and here I have d2y, this is d2y. So to find the resultant vector, I will draw a line joining these two points. This is dr. This is the resultant displacement. So the resultant displacement is now calculated by dr square using the Pythagoras theorem. Dr square is equal to the total resultant force, that is this is dx. Why I don't know why I call it d2x. This is dx, the total displacement along x, and this is the total displacement along y. So these are dx's and dy's. Here I have, this is dx, the total resultant displacement along y, along x. This is the total displacement along y, and this is the angle that the resultant velocity displacement makes with the positive x-axis. That's theta. So dr square using Pythagoras theorem, I know that dr square is the same as dx square, the total displacement along x plus the total displacement along y square. So taking the square root of this one, so dr is equal to the square root of dx square is, that is dx is how much? 124 square. I can just leave the units plus, and dy is 22.5 square. So please, you can do this. Let me use a calculator. When we 124 plus 100 times 124 is, you can calculator. 124 multiplied by 124 is, will give me 1. I will put it here. Was 15,376 plus. This is the same as, I can write this as 15376 plus 22.5 multiplied by 22.5 is equal to, then it will be 506.25. Then you add these two and take the square root of plus 15,376 is equal to, the sum is equal to, this is the sum is the square root of 15,588 sorry, this 882.25. Then take the square root of this one, take the square root of the answer, you will get 126. Then the resultant will be 120, almost 126, that is meter. So the resultant displacement is 126 meter. That's all. Now the next is, the resultant displacement is 126. It says, what is the displacement from the starting point? This is the starting point. This is the starting point. So this is our starting point. So this displacement is now, is given by 126 meter. Now we have to find, because displacement is a vector physical quantity, we have to use tangent of this this graph in order to find the angle that this resultant displacement makes with the positive x-axis. That is, theta is, shortly I want to write it in a short way, theta is given by the tan inverse of, theta is given by, the value of theta is given by tan inverse of dy by dx. That dy is 22.5, d to y, I mean dy is actually, the total displacement is the same as, that's 22.5 meter, divided by the total displacement along x is 124 meter. Finally, theta is, take the ratio of this, divide, and it's inverse. That's 22.5 divided by 124, then I'll get, that is, theta is tan inverse of almost 0.181. Then theta will be now, theta is now, this is the same as, when you take this, theta is now the same as, take the inverse of right shift, and you will get arctan of 0.181, then you will get 10.25. Theta is 10.26 degrees, almost, that is. So this resultant displacement is, the total resultant displacement from the starting point is 125 meter at an angle of 10.6 degree above the positive x-axis. That is, this is 10.26 degree. So this is complete answer, because an answer for a vector quantity is described by or given by a magnitude plus direction. So the direction is explained or given by the value of this angle, the angle between the resultant vector and the positive x-axis.